So thank you everyone for coming today. And also thank you for ArchiNet for having me in this fantastic series. My topic for this evening is architecture for the future in the realm of technological advancements and biomimetics, underlined with my experience and my knowledge across these years that I would like to share with everyone coming tonight. And the reason why I picked this topic is because I wanted to share my knowledge with other architects and students and share and spot the light on where the world of architecture is going and how it's shifting. So architecture has started taking a different course from the one that we are used to. And I believe that one of the major reasons for that to happen is because of the technological resources and advancements that we have today. My journey during my studies and practice documents this shift from the traditional design methods to the integrative design method. And I will be sharing all of this during this design talk. So I would like to start with one of the reference from his book, Radiant City, that I believe everyone probably has encountered and saw over the internet and is aware of. And this drawing has always fascinated me. The reason why this drawing intrigued me is because it's showing how every architect has a vision of how a city, its building, and urban fabric will look like in the future. So Le Corbusier was and is one of the fathers of the modernist movements. He depicts in this example his vision of how an ideal city with integrated futuristic mobility systems that he imagined having with flying vehicles and cars and trains going through skyscrapers for a fast and easy transport to accommodate the modern and futuristic life that at his time was envisioned. And even though most of his dreams and drawings of an ideal city were not realized during his time, we can start already seeing some of his visions coming to life 90 years later, proving that architecture is progressing very, very slow and is taking enormous amount of time to advance when compared to other fields such as aviation, aerospace, and automobile. And so there are multiple reasons that have caused this century gap that I believe that was the reason behind it, like society approval to change, having political conflicts, probably no resources or a major gap between architecture and other fields, and being stuck with designs that we started seeing in history books and many others. But the most important one, in my opinion, is the lack of advanced technologies integration. So if we want to have a glimpse and contribute to what architecture will look like in the near and far future, we must integrate the technologies and resources we are provided with. And so if we start incorporating new technological tools and equipments, we can explore new horizons in architectural design and have a faster moving architecture than the one we are used to and we see all over us. So before we go into architecture, I wanted to share with you some examples of other advancements in other industries. Aerospace and automobile industries have advanced way faster than architecture did. And for example, we see the BMW cars are manufactured with robotic arms for a fast and automatic manufacturing process. This is happening through incorporating the latest technologies, automobile industries that were able to move forward and gave them more time to explore design geometries and complex forms that were optimized for their functions. And in the last decade, we also saw that the aviation industry was inspired by video gaming applications and incorporated virtual reality into the pilot training. VR flight simulators are becoming the future of pilot schooling. During the training, flight simulators allow students to interact with a real airplane cockpit. This way of training saves fuel, can replicate hazardous conditions and system failures without putting any real-life passengers at risk. Of course, unmanned flying drones have been around for more than 2 decades, but their roots date back to the World War I, when both US and France worked in developing automatic and manned airplanes. And drone technology has developed in the last few years to the extent that individual commercial entities and governments have come to realize that they have multiple uses, such as express shipping and delivery, gathering information, even rescue operation, geographic mapping of inaccessible terrain and locations, and much, much more. And now we started seeing a merge between the fields of aviation and automobile. For example, we see here that Lilium is already crossing this box by offering the first all-electric vertical takeoff and landing aircraft with room to fit 4 passengers and a pilot, making it the first 5-seater flying taxi providing a powered ride, sharing, and air taxi service that is booked through a smartphone and will be offered to the public in 2025, taking mobility and transportation to another level. So these fantastic examples in other industries bring up the question of how can architecture benefit from this technological platform and how can we utilize it in our fields? Well, architecture research institutes have already started researching this integration and that was during my master's studies. So when I was doing my ITech master class, I had the opportunity to learn, work, assess, and on multiple and following multiple architectural examples that I will present in the following slides. Starting with the Buga Fiber Pavilion, fabricated in 2019, this demonstrates how combining cutting-edge computational technologies with construction principles found in nature really enables the development of futuristic and novel digital building systems. The Buga Fiber Pavilion was robotically manufactured by weaving fiber composite filament, providing a highly effective and exceptional lightweight structure, making it approximately 5 times lighter than a conventional steel structure. The building components are produced by a robotic coreless filament winding. And this novel additive manufacturing approach, pioneered and developed at the University of Stuttgart, is achieved with a nonlinear workflow where architectural design, structural engineering, and robotic fabrication are developed in a continuous computational feedback, making the pavilion structurally tuned and architecturally articulated because of its fiber arrangement. This arrangement of the fibers was individually calibrated to the piece's requirements, defining each component's fiber density and orientation, emerging with a filament interaction, defining the shape of the building and eliminating the need for a mold or a core, resulting in a bespoke form and individual fiber layup for each component without any economic disadvantage and no production waste or material offcuts. Moving on to the second example, we see here ICD ITKE Research Pavilion 2016-2017 that stands out for its long span structure and for the composite material implementation, as well as for the collaborative robotics setup. The material properties of fiber composites is astonishing because the composites have been heavily used in highly engineered applications, such as the automotive and aerospace industries. And they also have an outstanding potential in architectural applications. Lightweight fiber composites, they provide unparalleled performance within architectural scale productions, allowing to provide performative architectural outputs, where material self-weight is of high concern for large span structures. Here, the collaborative setup came out as a result of requirement because of the long span structure. It was best suited to use multiple robotic systems that could interface and communicate to create a seamless fiber laying process. The fiber process was passing between 2 robots and a drone to ensure a continuous material structure, as you can see from the picture. So in this video, you see the pavilion standing out because it was inspired by the leaf miner caterpillar to create this pavilion. A volumetric winding fiber directionality, as well as, hello? I think can you hear me?
Yes, Rasha. Everything is
Oh,
fine.
sorry, it must have disconnected from my side.
It's okay.
Okay. So following up, here we see that the reinforcement was achieved through computational feedback loops, feeding into multiple machines, creating a fabrication processes concept that is based on the collaboration between strong and precise yet stationary robotic arms with limited reach and mobile long-range drone machines with limited precision. This adaptive control and communication system was developed to allow multiple industrial robots and a drone to interact through the winding and fiber laying processes and through an integrated sensor interface that enables the robots and the autonomously flown drone to adapt their behaviors in real time to the changing conditions during fabrication, resulting in a collaborative machined architecture. So one could also argue, after the first two examples, whether we are able to teach these robots. The answer is absolutely yes. Here is our last example of this list, presenting a machine-learned robotic recognition for building operations. In this example, the implementation of neural network approach and machine learning to provide digital building operations picks up on a simple old traditional method of stone stacking and transform it into a machine scenario to provide an autonomous construction in areas that are hazardous to humans, such as the moon or Mars. And so this process is through teaching the robot using scanning processes and save data in a computational base, where once similar items in shape, when they are on the ground, they will be detected in the next step, and the robot will create a stacking simulation for a quick checkup and see if the item fits in one of the configurations that are based on developed principles, which are enhanced over time, resulting in a collaborative robotic scenario. So these three architectural research examples that I've shown earlier, out of many, many more, open doors for design innovations and will transform the way future built environment is thought of, materialized, and designed, resulting with a multidisciplinary design culture and a more collaborative design environment. Shifting our methodology into a system where design engineering, material, construction, fabrication, and building coexist and work together to create outstanding architecture that is tuned in more with our time. So being exposed during my past years to these innovative and novel environments, it really helped me shift my traditional methodology to a more advanced one, learning that architecture must be a collaborative field with our industries. And thus, I would like to present in my next and final slides a documentation of my progress and shift to develop the technical and intellectual ventures that I have been exposed to. In these lines, I picked up 4 relative projects of which I worked and collaborated on to present examples of how architecture can coexist in a more collaborative field and how the merge of biology, architecture, and technology could result in fascinating outputs. Starting with biomorphic as beauty. Biomorphic is the use of formal geometric elements found in nature as a source of inspiration for aesthetic properties in designed architecture. For example, and this is a historic example of biomorphic architecture, dates back to Egyptians, Greek, and Roman cultures using tree and plant forms in the ornamentation of structural columns. Here I present an example on a biomorphic architecture the Qataf sculpture. Standing as a concept for an urban furniture to provide shading and seating, this was based on extracting design principles from the famous and national Jordanian flower. The black iris, hoping to raise awareness to my country's national pride through creating a public art piece. The design took advantage of the existing computational tools and softwares to best optimize the resulting form of the black iris, and not necessarily providing an architectural solution. Next, we have the biomimicry as a system. The term biomimetic architecture refers to the study and application of construction principles, which are found in natural environments and species, and are translated into the design of sustainable solutions for architecture. Biomimetic architecture uses nature as a model, measure, and mentor for providing architectural solutions across scales, which are inspired by natural organisms that have solved similar problems in nature. And so during my studies at the iTech Masters in Stuttgart, one of our research topics were biomimetics, where we were asked to select an animal from nature and translate their method of construction into an architectural result. For this subject, we picked weaver ants. So weaver ants have an extraordinary building behavior in constructing their nests. These small architects build their houses through structurally aggregating themselves on a plant and slowly bending and pulling leaves towards each other, while squeezing their babies to produce silk and glue the leaves together, transforming a simple 2D leaf into a 3-dimensional shape. And this makes it quite fascinating to me to see how those small architects behave and cope with different environments to build and solve their houses. So after documenting the ants' behavior and making various system models, our class was able to replicate that information onto a conceptual architectural simple start model that can adapt and reconfigure in shape with simple bending movements and result in 3-dimensional spaces. Following that model, many designs and iterations were studied to better understand the movement in relation to the material properties and overall design. There were also various material tests that took place to check against the material flexibility to the bending process, and fiber composites, of course, came first, with their resilience to bending processes and lightweight. After that, various teams collaborated together, and as a design was selected to contribute to the research of adaptivity and reconfigurability, providing 2 spatial conditions, an enclosed space and an open space, resulting with a design that heavily relies on the material and structural properties of lightweight systems that are basically using bending active properties of the composite materials. So here we see that the 2018 ICD-ITK Pavilion contributes to this research of adaptivity and reconfigurability, creating an architectural system that can change its physical properties and is supporting the formation of different overall geometric configurations during fabrication and on-site construction processes, enabling the pavilion to adapt to various environmental conditions through ground motors and sensors attached to the carbon fiber plates. Moving to my third architectural experience build-up, design as environmental response had a great impact on my shift. I realized that architecture always strives to move towards radical increases in resource efficiency and work in a closed loop model rather than a linear one, and rely on solar energy instead of fossil fuels. Here, I would like to talk about my work experience on the B.A headquarters designed by Zaha Hadid architects to build a dynamic architectural body that fits within the desert environment. So while working at Zaha Hadid Architects, I was quite lucky to fall on this particular project because this architectural masterpiece was designed with environmental considerations that were woven into every aspect of the design using renewable systems. The BIA headquarters was designed as a response to its natural environment by minimizing energy and resource consumptions. The design was informed by its desert context as a series of intersecting dunes oriented to optimize the prevailing north winds, and was designed to provide the interiors with high quality daylight and views while limiting the quantity of glazing exposed to the harsh sun. As for the exteriors, the finishes of the building have been selected to reflect the sun rays and help further reduce energy consumptions by providing a local heat profile that is akin to the natural desert environment. I would like to say that even though the BIA headquarters is a man-made architectural system, it's actually representing a great example for a sustainable environment and environmental construction. Which brings me to my last part of my design talk for this evening and my knowledge share on how can we merge architectural research and design principles to give birth to a bespoke architecture that adapts to the new technology. Well, Lilium Air Taxi is actually focusing on creating an integrated system offering a high-end electrical jet and an adaptive vertiport that incubates this flying technology. And the head of architecture of Specs, Rico Sebe, and previous associate partner at Foster & Partners, believes and focuses on creating this bespoke architecture that keeps up with the pack of advanced technology. Working closely with him, we focused together on developing simple yet functional and adaptive architecture that incorporates the vital elements for running its future aerial taxi. And our designs are based around a set of modules which are standardized, making it simpler and more affordable for developers to plan a vertiport for their specific site. The modules can be also prefabricated off-site, reducing the cost and allowing for a rapid on-site construction. This is the kind of architecture that is extraordinary. It's adapting to the high commands of bespoke and advanced technology through a base of optimized design solutions and studies, setting up the base to architecture for the future that is aligned with our age and our technology. And here, I would like to follow what I have presented earlier and end my design talk for this evening with a question for the audience that came today with what can we do as architects next? So I would like to thank everyone for joining and tuning in. And please, please don't hesitate to reach out on my social media and platform and connect. Thank you.
Thank you, Rasha, for this inspiring presentation. We already notified everyone to share their questions if they had any.
Yeah.
So we have a question from Muhammad Atta. What's the difference between biomorphic and the morphogenetic design?
Yeah, that's a great question. So biomorphic is what I have explained earlier. It's basically taking a form as it is, and it's basically kind of copying what the plants have or what a geometry has in nature right away into architecture. And the morphogenic is basically from its name, like you need to basically cut the word into half to understand it. It's morphing, it's something that is changing, and it's changing in its genetics. I hope I explained that well.
Okay. We are waiting questions if anyone have. I think the second project that you shown us, or the first one, which is the fiber welding,
Mm-hmm.
There's a question from Amira, how it is attached, uh, the kind of welding to the materials.
The Buga fiber pavilion.
Yes.
Can you repeat the question, please?
The,
Because
the
I
question
can't
is
see the
how the
questions.
materials are, yeah, how the materials are attached actually once the pavilion is
Okay,
built.
perhaps I can go back
Yes.
to the project to probably explain better what. So we have the
Yes.
Buga fiber pavilion, this one, right?
Yes.
Cool. So it's also a great question, Amira. Here, the winding of the filaments are hooked up to on two pieces that are, as you see, on that core. And you have the robot moving from one side to another that is winding around the hook of each piece and then going back. So perhaps I can move the video a little bit, which could help explain more what I'm trying to say.
Mm-hmm.
So we have these two sides that are of double curvature, and then the robot is winding around the pins that are on each side of the component. And this is done with computational tools where there is a feedback between each component. So each component is basically optimized for its location with a fiber winding. So we see the glass fiber and carbon fiber for each part. Glass fiber has really great taking tension forces, and carbon takes compression forces. And each component has been well placed for its specific location on the component.
Okay, we have question from Professor Abdel Mohsen.
Assalamu alaikum.
عليكم السلام.
Thank
تفضل
you very
بروفيسور.
much for a very interesting lecture. And it is certainly one of the directions of the future. Now, allow me to be naughty, a little bit naughty with you, and for the sake of benefit of everyone, including myself from you. Roger Garaudy wrote once about a trilogy or a system of three elements: wisdom, science, and technology. That wisdom should direct science, and this wise science should direct technology. In developing countries, we are mostly fascinated with technology. Without enough science and in most cases without enough wisdom. In developed countries, they have the technology and the science, not always the wisdom. So my question is, I can see merits, I can see great potentials in environmental terms. However, what has been shown here, with all due respect, everything is beautiful. Everything shown is very, very beautiful. But the real environmental response is not that great, really. The project of Zaha Hadid, although it is beautiful and it has some logic, I must admit, exposure, least exposure to the sun and right exposure to the preferred orientation. But then what? Yani, there are many other things, ventilation, the possibility of double roofs. The solution, there are more sophisticated systems that respond to the environment than what I see here, which is beautiful as shapes. The other question, so the first question is the environmental response. The second question is the social response. How can these technologies help in social housing? Social housing may constitute something like 70 to 90% of our environment. And if we don't do something serious, we end up with squatters. That's all, but I appreciate very much your work. Thank you.
Thank you, Dr. Abdel Mohsen, for the questions. I hope I understood your questions correctly. So the first one is, how is the BIA headquarters corresponding to the environmental context, not only on a ventilation system? Am I right? Or I'm not sure. Perhaps you can help me understand your first question.
Uh, what I'm trying to say is that in environmental response, architectural response to the environment, there are many things connected together. And what we saw in the project of Zaha Hadid is probably one aspect, say a limited aspect. It's beautiful, but the environmental response is limited, and in traditional solutions there are richer solutions. I have to say that. Thank you.
Thank you, Doctor. So I would like to personally say that the BIA headquarters has actually won a LEED sustainability certificate for before even it was the first building that got the certificate before it was completely built. There's other aspects that perhaps I didn't cover up during my design talk due to the time limits. But the BIA headquarters has, of course, other environmental responses that are incorporated in the building. The building acts as a system. It's not separate elements that are put together. Of course, the form is inspired by its nature, it's inspired by the dunes, but also is taking into consideration the light that is coming inside because it's a harsh environment. There's also a lot of systems that are incorporated in the building that, that makes this project responsive to the environment. That I'm happy to go over about some of these details with you on another time because there's plenty of them. As for the second question that you've asked, it's a great question of how can we incorporate these technologies in social housing. I really love this topic because I believe that I totally agree with you on the social housing. It's something that is very important, especially during this time, because we're spending our times quite a lot in-house, and we're discovering that some elements in our houses are not quite to our likings for some reason. And I believe that there's plenty of technologies that we can use to build a very environmental and very healthy house for us. And here, the design could be something where it's more of an integrated process rather than saying I'm designing a 4-bedroom apartment or I'm designing a 2-bedroom apartment, but rather than focusing on that I'm designing this house for a human being and I'm using the technologies that I have, whether with robots or with drones or whether even by hand, whatever the technology that you're using it to build a sustainable house, if this is your question. But if your question is to how are we using the technologies to build houses that are economical, there's plenty of examples. We can use 3D printing, for example, clay 3D printing. We can use, for example, melted plastic to build our houses. There's plenty of researches that are out there that talk about this topic. Unfortunately, this is not my realm of expertise. However, and that's why I'm also focusing that this is all these examples that we've seen before going into the last bit of this talk. It's all research. There's still not a profound ground that we can clearly incorporate this in our daily architecture usages and applications. And so that's why I ended my talk with what, as architects, can we do to use these technologies, because I think that's where the world is going. I hope I answered your question.
Yeah. Okay. We have other written questions here, which is I'm trying to pick one. I just had scrolled through. for students and seniors or the interested ones, can you recommend some books or applications how their career can be developed, combining such technologies, learning about these aspects, etc.?
I'm sorry, it cut off. Can you repeat the question, Muhammad?
Okay. The question is, can you give us sources to study these types of architecture courses, books, any recommendation, how students and even practitioners can develop or develop their careers to learn about these practices?
Yeah, who asked that question?
Actually, plenty of ones. So I just combined them in one question.
Okay, so I'm going to be very, very honest with everyone. I don't like to read. I really, really don't like to read. And I think that it could be something that it's it's a disadvantage that I have, but I just don't have the time or patience to read. However, I can recommend to just surf the internet and just look through what institutions and research institutions are doing. So, for example, look into the university that I studied in, ITK Stuttgart, look into ETH Zurich, look into AYAC in Barcelona, the Architectural Association in London. You can look at the Bartlett. There's plenty of universities that focus on this kind of research, and they have also a plenty of books, online books that you can download and read from.
Okay, there's something else I wanted to ask, combining a couple of questions also. It's not only about the software, also about learning the materials and how to use them and how they can be fabricated to create such designs and technologies. So what is the best way to learn about the materials and also the best softwares they can learn about it and practice it?
Okay. So when I was in Jordan, I was exposed to the traditional architecture that every student deals with. For example, you have a project, you're asked to do a project, and then you design that project. However, when I went outside to Europe and I was exposed to this collaborative, more open field, and kind of understood that architecture is not alone. There's other fields out there that we can collaborate with and work together with to create something new. It kind of helped me focus on it helped me to be more open and focus on other topics as well. And I think like this, through my studies, I was also exposed to learning how to deal with the materials and how to understand what is the material that I'm building with and build a system for it, which could be a great base to what the form of the building will look like and kind of helps directing the geometrical output of the building.
Okay, there is another question from Muhammad. Is Biomorphic a bottom-up approach or top-down?
Oh, I love that question. Muhammad, it's not about, in this specific with biomimicry, not biomorphic, biomimicry, there's two different approaches, as you have mentioned. There's a top-down and there's a bottom-up. When we are working, we are using biology as a base, let's say. So it could be a bottom-up approach. So we're using in the weaver ant example, it was a bottom-up approach where these weavers were the base for, let's say, the design, as well as for the second project for the ICD-ITK Pavilion. But it could also be a top-down approach where you're designing something and then you notice that there's an animal or there's a creature that is also doing the same. So you're re-informing the design after you have designed it. So it could be two-way approach, depends on what you're using. So biomimetic is just a principle, and bottom-up and top-down approach is an approach. That's actually one of the first things that I learned during my master's studies.
Okay, there's a question from Tamer. To what extent do you think the biomimicry that you mentioned can be the answer to our environmental problem, and how to measure acritic effects of those organic free forms as they don't follow the Euclidean geometry of flat two-dimensional spaces?
Oh, hold on. Can
Yeah,
we?
was a long
Yeah.
question. So let's just
Let's
take part
start with
of
the
it.
first one.
Okay. To what extent biomimicry can be an answer to our environmental problem?
It's not necessarily an answer. Biomimicry is basically a principle that you can apply on your design question. So, for example, if you see that you have a problem in your design, that's why biomimicry is a solution. It's providing a solution for your design. And
Okay.
the other question?
How to measure or critic effects of those organic free forms as they don't follow the normal geometric flat or the two-dimensional spaces?
I'm not sure I understood the question.
Okay, maybe we can ask Timer if he can clarify the question more. So there are plenty of questions.
How can we measure the non-Euclidean geometries?
Yes.
In which example?
He didn't mention which one in your project. So I think these free form of similar to the one that you're showing us now.
Measuring what? Perhaps I can help explaining in general when we have non-Euclidean geometries or non-uniformal or organic geometries. When we are trying to fabricate them at some point, there's two ways of fabricating these free-form organic shapes. One is using molds. And when we're using molds, like for example, in cars, in the cover of a car or a plane, they have these dynamic shapes and they use molds. And molds become really, really expensive and could result in a very uneconomical output. But in another way is we try to subdivide a geometry that has a free-form kind of shape. We try to subdivide it and split it into parts, and then try to figure out the form of each part that we have, and create a more Euclidean shape of each part. So for example, this shape has this curvature that we see on the screen. It has a curvature, and the components are creating the curvature of the form. And that's probably the answer of your question, Tamir.
Following to Professor Abdul Mahsen question, we had a couple of questions about these technologies and how we can use them in the developed countries, etc., in Middle East. What would be the first step for us to start practicing or using these technologies besides learning them?
How can we practice? I have been quite a long time away from Jordan and the Middle East, but I've heard that there have been quite a lot of technologies. Like I've heard that there are robots in Jordan. I'm not sure how true that is, but when I say technologies, it's not necessarily referring to the robots or VR. I think everybody has access to VR in a room or in a play with a PlayStation, because this is the first thing that you have when you're buying a PlayStation, or even a drone. I'm pretty sure everyone has a drone. And as I've showed in the previous examples, on this example in particular, there's a drone that is moving the filaments from one robot to another. I think the question is, what can you do with a drone and what can you do with a VR? And not necessarily only with a drone, but with a VR, maybe you can create your own robot, mini robot, or maybe you can use, also the softwares are a technology. The softwares we're using, we're not 20, 50 years ago, probably. We've started only recently using these softwares in our daily lives, right? And I think these are also part of the technology that we're dealing with on our daily basis. So the question goes back to the person that asked this question is, what can you do with some of these examples that I've showed to create a new type of architecture?
Okay, the last question we had from Muna. When we talk about the biomimicry, does it always mimic the form, process, and ecosystem, or can it only mimic only aspect that one aspect and still be called biomimicry?
That's a great question as well, Muna. So biomimicry, it can mimic anything. You can mimic. I can give you an example. For example, as a base, the fast trains in Japan were built up based on a biomimic approach. They use 3 animals: the penguin and a bird, and they also used another animal that I can't recall what it was at the end, but it was only to make the train faster. And it actually went 10 times faster than a normal train. So biomimicry, it can be used in our daily basis, in our daily lives. And as a human, before we had houses, before we had homes, before we had technologies, we looked into how animals and other animals build their houses and they build their nests, and we got our inspiration from there. And that's why I think that even that we have technology in our daily lives and we have this amazing platform, I still believe that we need to go back to nature to understand where we are and the base of what we're designing. And I think also this was one of the reasons of this traditional shift that I had. And when I say traditional shift, doesn't necessarily mean that I don't do what I did 8-10 years ago. I'm still doing it. I'm still designing the same way you're designing as a student. However, I'm implementing these technologies and I'm implementing the knowledge and experience that I've received throughout these years to create the designs and architecture that we have today. And as I've shown with the Lilium vertiports. And I think this is very, very extraordinary because we will have these flying cars, which is a technology that will come in 2025 to us. And we have to think about the architecture that is going to incubate it to make it happen. And these vertiports come in such a function to this technology that it's really important. And the way Lilium is thinking about this as an integrated process is really, really fascinating.
Okay, Rasha, thank you a lot for being with us tonight and for everyone who attended.
Yeah, I would like to thank everyone that attended. I hope I didn't take too much time. And thank you for the lovely questions. And please connect on my platforms. I'm happy to answer any further questions that you have.
Okay, thank you.
And thank you, Muhammad, for the invitation, for this lovely
You're
invitation.
most welcome. Thank you.
Thank
Take care.
you.